Okie dokie, here we go. Video number 2. So we just finished talking about how we can determine whether a function is increasing or decreasing if the derivative is greater than 0. By the way, what does that mean? When a number is bigger than 0, that means we're saying, is the derivative positive? Or is the derivative negative? Because then that's going to tell me whether the function is increasing or decreasing. But the thing we don't know, or I guess we haven't talked about, is how do I figure out whether it's positive or negative? Well, we look for points that are critical to us finding that, which would be points where the derivative is equal to 0. And so we're going to talk about critical points in this video and how to find them. And then we'll put those two ideas together to find intervals of increasing, decreasing without a graph. So if f of x is defined at x equals c, so we know that f of x exists at this point c, then f of x has a critical point at x equals c if the derivative at c is equal to 0 or the derivative at c is undefined. So a critical point is a x value that makes the derivative equal to 0 or makes the derivative undefined. That's all a critical point is. So in order to find critical points, the very first thing we need to do is find the derivative and then set the derivative equal to 0, or if it's a fraction rational setup, then I need to know when it's undefined, and rational functions are undefined whenever the bottom denominator is equal to 0. So let's find the derivative. We have two examples here. Let's find the derivative of both. So we're going to find h prime of x. They want to know any values where h of x has a critical point. So that means this means h prime is equal to 0 or h prime is undefined. That's what we're looking for in number 1. But let's find the derivative of this. Well, I have a division here, so this is a quotient rule. I'm going to take the derivative of the top times the bottom minus the derivative of the bottom times the top all over bottom squared. Do I need to write all this? Maybe not. You can probably do some of it in your head because the next line would give me x plus 2 minus x, and that's going to make the x's cancel out, so I'm left with 2 over x plus 2 squared. I think I lost the plus there. There you go. So here's my derivative. Awesome. So I need to do two things. I need to figure out when is the derivative equal to 0, at what x is the derivative equal to 0, and at what x is the derivative undefined. Since we have a fraction, we know that fractions, whatever makes the numerator equal to 0 is what makes the whole fraction equal to 0. So if I want to know when h prime is equal to 0, then I should just set the numerator equal to 0. But the question is, when is 2 equal to 0? Never. So there is no critical point that causes the derivative to equal 0. Okay, so now I need to check when is the derivative undefined. Well, the derivative is undefined if I have a rational setup, a fractional setup, if the denominator is ever equal to 0, right? Because if I divide by 0, then that's an error, that's a vertical asymptote, and that is an undefined point. Well, I'm going to set the denominator equal to 0, take the square root of both sides, and subtract that 2 over, and we have one critical point. So are there any values where h of x has a critical point? Yes, there's one x value at negative 2. Why is it a critical point? Because it makes the derivative, it causes the derivative to be undefined. If I were to substitute negative 2 into the derivative, I would get 2 over 0, and that's an undefined value. And that's a critical point. However, there is no x value that I can substitute into that purple box equation derivative that will make the derivative equal to 0. So there is no critical point caused by that, but there's a critical point caused by undefinedness. And we found a critical point. Okay. So let's see. Let f prime of x equal x minus 1 quantity to the third times e to the 2x. Can you find any values where f of x has a critical point? So I usually tell students, pay close attention to what they are asking for. They're asking for when f of x has a critical point. So I want to know when f prime of x is equal to 0 or where f prime of x is undefined. Right? By definition of a critical point, that's what I need to do. But they don't give me f of x. They give me f prime of x. So I don't need to take the derivative. I already have the derivative of the function whose critical point I'm looking for. So therefore, I'm going to take my derivative and set it equal to 0. Whoa, wrong number. And now the question is, when is that equal to 0? Well, I'm kind of lucky because I have a product. I'm multiplying two things, right? And we said if something times something equals 0, that means either this is equal to 0 or this is equal to 0, which is one of the reasons why we factor, is to find zeros quickly. So I'm multiplying two things. Either the first thing is equal to 0, the second thing is equal to 0. Well, let's find, does any x value make this first factor equal to 0? If I take the cube root of both sides, I'm going to get x minus 1 equals 0. I'm going to add 1 over, and I get 1x value there. I have a critical point. When I go to the second part, e to the 2x, when is e to the 2x equal to 0? Well, if you remember your exponentials never hit the 0 x-axis. So therefore, this is never equal to 0. An exponential, remember how exponentials look? They look like this. Well, they never get to 0. The y is never 0. They get closer and closer to it, but they never get there. So therefore, there is no critical point on the second factor. And then I should check, when is f prime undefined? Well, this really isn't undefined because this doesn't have any issues by itself, and this doesn't have any issues by itself, and together they don't have any issues. So the function is defined everywhere. The derivative function is defined everywhere. It's just that x equals 1 causes the derivative to be equal to 0. So there's only one critical point here. So this is my critical point, I think is the word they used. Yes, this was my critical point. And again, some people call it a critical value. So why do we need critical points? Well, if our goal is, whoa, I grew. If our goal, man, this is being, there you go, there I am. If my goal is to find increasing, decreasing, and increasing, decreasing happens when the derivative is positive, and when the function is decreasing, that's when the derivative is negative, then if I can find where the derivative is equal to 0 or undefined, those are the places where it kind of changes, right? And so if I go back to my original graph that we started with, look at the derivative where the function changed from decreasing to increasing. That would be here, that would be here, and that would be here. What do I know about the slope at x equals 2, the derivative value at x equals 2 for this function? It's undefined because it's not differentiable, right? So the derivative is undefined at that point. That's a critical point. What about this one? Oh, it's also undefined. Why? Because there's a sharp turn. There is no derivative. So the derivative is undefined there. What about the slope down here at x equals 7? Oh, the derivative is 0 because the tangent line has a 0 slope. So these three purple circles are the critical points of this graph. But notice that they also kind of help me determine when the graph changes from decreasing to increasing or from increasing to decreasing on my interval. And so that's why critical points become critical to us finding intervals of increasing and decreasing, but also help us find where there might be some minimum points and some maximum points that we're going to get to in the next set of videos.